Hello, my name is Cary Jensen, and welcome to CodeRage 9. In this session, I'm covering nested datasets in ClientDataSets. I'll begin this presentation with a brief overview of nested datasets. I'll then demonstrate how to create nested datasets from master detail tables. I'll then show you how to save and load these files with nested datasets and what those files contain. I'll then look at how to define new structures for nested datasets at design time as well as at runtime. Nested datasets are a type of T field, and that T field contains a dataset. It's like having a field whose actual content is T dataset descendant, and in the case of client datasets, that dataset field is essentially a nested client dataset. Each client dataset can have up to 15 nested dataset fields in its structure, and each of those nested dataset fields can have up to 15 nested dataset fields. As a result, it's possible to get very complex and highly nested structures of nested datasets. There are two primary purposes for nested datasets. The first is to be able to maintain master detail relationships in a single unit, especially valuable when you're using cached updates. When you have nested datasets in a client dataset and you place it into the cached updates mode, you're tracking changes to not only the master client dataset, but as well to all of the nested datasets. And this allows you to make a single call to apply updates on the master dataset and have all the details and the master changes applied in that single call. Furthermore, if you are applying updates within a transaction, all of those changes will be performed in an all or none fashion. The second purpose for nested datasets is to store and transport related data in a single unit. Let me give you an example of how this might be used. Let's say that we are a transportation company and we're responsible for shipping orders by truck. A truck may have multiple locations where they need to stop, and at each location there'll be one or more orders that they have to drop off, each order consisting of one or more packages. What we can do here is we can take all the information about that vehicle's stops and orders and all of its details and package it up into a single client dataset. That client dataset may be used by an application that the driver employs to identify where they're going to go, what they drop off when they get there. And because of the capabilities of the client dataset, not only would we have this highly related data stored in a related format, we could also attach other important things. For instance, we could store in blob fields a PDF of the map of the drop-off location. We could also have PDFs of the invoices, all sorts of information, but we were storing this in a single file that could be used by an application by the driver to maintain and manage all of that data. And if the driver also needed to make data entries, maybe keep notes about things that happened during a particular delivery, that could be added into the client dataset, and then the change cache could be used in order to see what those changes were, and that could be used to update a primary database from which all this data is extracted. Once again, that's just one example, but nested datasets make it very convenient to package up highly related data into a single file or a single stream. Okay, we're going to get into Delphi now, and we're going to actually see how this is done. And I'm going to do this manually. I've got some projects that I've set up in advance that have some very basic infrastructure, but I'm going to show you step by step how all of this is done. And we're going to start by creating nested datasets from master detail links. This is a very useful tool when you have related data in a database that you want to extract into a client dataset, maybe work with offline or work with that data in a data snap a server client type application, but nonetheless you still need to know how to get that data into a client dataset with its nested dataset fields holding the related detail data. Now there's two ways of doing this, and almost all T data sets that you're going to encounter have this capability. Certainly the Borland Database Engine T tables and T queries had that capability. We have that capability with FireDAC now as well as the other data access mechanisms supported by Delphi, but I'm going to use FireDAC in this particular example. So just to begin with, I have a connection, and this is already wired up to connect to the DB Demos Interbase database that ships with RAD Studio, and I have these three data sets that are pointing to that connection. This one's a customer, we're calling it customer table. It's a FireDAC table. Honestly, I prefer FireDAC queries to FireDAC tables, and I do have a FireDAC query that I'm going to employ here, but I just want to demonstrate that we have two different ways that we can wire up components, and all of FireDAC's data sets support the two distinct ways. Now what I have here is, this is my customer table, and this is simply a table that points to this is a FD table that points to the customer table in the database, and there is a data source that points to the customer table. Now that's critical, because in order to wire the orders table to the customer table based on their common cust.no field, I need to be able to point to this customer table somehow, and this is what this data source is doing. So my orders table here is going to point to that. First of all, it points to the orders table, but in order to create the master detail link, we're going to use the master source and master fields properties. Master source points to the data source that is associated with the master table of the master detail relationship, and then we use the fields editor for master fields to choose the common field that is provides the link. Essentially, this is going to be the foreign key of the orders table associated with the customer order, or the customer number in the customer table. We also want to identify an index, and we're going to create a temporary index on cust.no so that that link can be performed. Now what I have here, I have these two grids that are associated with data source 1 and data source 2. Data source 1 is pointing to the customer table, and this top grid is pointing to data source 1. Data source 2 is pointing to the orders table, so that we can see that a master detail relationship is actually being created here. So I'm going to begin by activating the customer table, and now I'll activate the orders table, and what we should get is just the orders for the very first customer. So the active record in the customer table is associated with customer number 1221, and that's all the records we see here. Now if I bring up the fields editor for the customer table and start navigating, you'll see that the detail table is now linking up to that table. So we have created our master detail link. Now you may notice we haven't even involved the client dataset yet. What's important here is that if a client dataset's dataset provider points to the master table of a master detail link, the detail table will be represented in the client dataset structure as a dataset field. So this is what we're going to do here. So the customer table is, or this customer provider is pointing to the customer table, which is the master table of a master detail relationship. And my client data set is now pointing to that customer provider, and I'm now going to activate the client data set. Now what we got was very special. We have now a client data set that contains a data set field, and we can see that field if we go to the fields editor and add all fields. There's the field right there. That is a data set field. Now what I'm going to do is take data source 1 and point it to the customer table, basically, or essentially the customer CDS, or client data set. Now I have, now that I'm pointing over there and I scroll over, we can actually see that there's this data set field. Let me go ahead and run this project and scroll over, and I'll show you that I can click the ellipsis on that dataset field and actually see the contents of the dataset field. You may also notice that the word dataset appears in uppercase. That indicates there's at least one record in that dataset field. Okay. This lower grid is still pointing to this to the orders table. What I want to do now is point it to the nested dataset field specifically. And the way that I do that is that I create another client dataset. In this case, I have a client dataset here called order CDS, and I'm pointing data source to the order CDS client dataset. But what I'm going to do with the order CDS is I'm going to point its dataset field to that persistent field that I created up here, this orders table field. And when I do that, I'm again now showing the nested dataset field, but I have I can use the controls of my own design. I don't have to use this default little grid that popped up here. I could use individual fields. I could use any kind of control that I like through live bindings or using these VCL data aware controls for this purpose. This is my fields editor for the master table, so I can once again navigate through the records, and you'll see that the detail table is displaying only the nested dataset fields. Well, I demonstrated this master detail relationship using master source and master fields. There's another way you can do this as well, which is to employ a linked parameterized query. So what I have here is a query that currently doesn't have a SQL statement, and I'm going to add that SQL statement now. I'll say select all from employees where no equals, and then I'm going to use and actually it doesn't matter the capitalization here, where it uses a parameter. Very importantly, the parameter has to be the name of a field in the master table. So let's go ahead and say that's the query that we want. Now, how do we indicate the master table? Well, once again, we go to master source and we pick a data set source that is pointing to the master table of this master detail relationship. We also should have our index be indexed by the foreign key. And now we'll activate this data set, and we don't quite see it yet. So let me go over here. And let me redo that. Now what I can do is, since this is a subdetail of the orders table, I come over to my client dataset for the orders table, and if I now add all fields, we'll find down here our nested dataset. So once again, let's run this and come on over. And then come over, and there's the details. Now we can go back and navigate the master, and we'll see that the details and subdetails are all synchronized. Now that's how we can link up master detail relationships. Let's talk about the data structures themselves and how we can store this. You know, one of the very important aspects of client data sets and other data sets is its ability to persist itself. Well, when we're working with nested data sets, we always really concern ourselves with the top level data set, specifically the client data set that points to the provider, that points to the master table of the dynamic master detail relationship. And I'm going to come over to this client data set, and I'm going to say that I want to save an XML file. And I'll go ahead and I will store it into this directory, and we'll just call this data.xml. And let's go take a look at that file. What we see in this file is the structure of the master table, the structure of the nested table, and the structure of the nested table. And this would be, doesn't matter how many nested data sets we have, but the structure is being represented in the metadata section of the data packet. Same thing is true about the actual row data. Now, we did not use cached updates here, and we have not made changes to the data. If we did make changes to the data, that change cache, the delta, would be represented in this file as well. So what's really important about this is that we have now persisted this file with all its richness and its associations. What I can do now is let me just take this project and I'm going to discard it, and I'm going to open up one of my other projects that just gives me some components. I'm going to take this client data set, I'm going to load what I just previously saved. So I'm going to go to the file name property and master detail link and open that up and then say make it active, and what we get, you see there's a nested data set. And if I were to hook this client data set up to that client data set, we would again also see the nested data set contained in here. And if we were to make changes and then call save the file, and then later, maybe days later, reload that file into a client data set, again, it would not only have all the data and all the relationships, but any changes we made to the data would also be represented with sufficient detail in order to allow us to apply all of those changes to the underlying database using the dataset provider. So this is what we just went through. The data and metadata saved, captured updates are enabled, that they're included in the data, and it's there when we load that data again. Okay, I've shown you how to create nested data sets from a dynamic master detail relationship, but we need to be able to create our own client data sets with nested data sets in order to create new data structures that are not based on an underlying database. For example, imagine that you want to write a simple little contact management application that you want to give to your friends and family. And that may conceptually contain two tables, one which is the contacts, and then a subtable that would be the telephone numbers. Well, wouldn't it be nice if we could just use one client data set and have the application entirely use just one client data set file to have that master detail relationship of contacts to phone numbers, so that you could have any number of different phone numbers for any given contact? Well, if that's the case and there's no actual database anywhere, we need to be able to create a structure manually. So essentially we have the same tools that we use to create any data set at design time or runtime, and that is we can either use field defs or we can use T-fields. And I'm going to show you how to do this both at design time and at runtime in code. So that's our last real slide that I have here, so we're going to come back over here. And I'm going to bring back up this design time nested data sets, which is kind of, I'm going to use it as a workspace, a workbench for demonstrating this. So the first thing I'm going to do is I'm going to demonstrate how to create these dataset fields using field defs. So I'll come in and bring up the fields def editor, and I'm going to add a couple fields. I'm going to make these structures very simple, by the way. So the first field, I'm going to just call this ID, and I'm going to make it a string field, and I'm going to make it 6 characters in length. And then I'm going to make this field, guess what? I'm going to make it a nested data set field. And we'll call this details. Now I go into this child defs property, and here I define field defs for the child. And this one here, I'll call this, make this again another string field, and I'll call it sub ID. And let's make this also 6 characters in size. We now have our structure defined for the data set. All we need to do now is say create data set. And we've created a data set. Notice this is not in caps because there are no records there. Now this data source 2 appears to be pointing to client data set 1. Let's point it over to client data set 2. And while we can certainly work with the data just the way it is right now, we can put in, say, for an ID, and then come over here to the dataset field, open it up, and put in some numbers here. Post that. That's not really very convenient in terms of accessing that data here. So So I'm noticing this, for some reason it looks like it has data in it too. So, well, what if I want to show that sub-detail down here? Well, I do the same thing that I did just a moment ago with the dynamic link. I come over and I just assign this client data set to that data set field. So we'll come to the fields editor, make persistent fields, and now we can select this data set, and there's our data set field, and there we have our sub-detail. So that's how you do this using field defs. Let's now do it using T-fields. Okay, let's point this over to Client Dataset 2. Okay, so I'll come in and I'll bring up the fields editor and add a new field. This is a data field, and I'll call it ID. Essentially, we're going to create the same structure that we had in the last example. Now I'll come in and say I want another new field. This time we'll call it details. And I will again set it to be a dataset field. Let's see, where is dataset? I'll just start typing dataset and there we go. Dataset. Okay, so I have my dataset field and my ID. So now I take client dataset 2 and I point it to that dataset field, the persistent dataset field, and now I can come into this fields editor and add fields for this this detail table. So I'll call this sub ID, string, and 6 characters, and accept that. Now I come back, client dataset here, and I say create dataset, and voila, we have our master dataset and our detail. Okay, now what we want to see is how do we do this at runtime. I have two applications, one that demonstrates the runtime creation of field defs, the other that's the runtime creation of T-fields. So here's our field defs version, and I'll run it so you can see it working. I'll create, and we got master, detail, and sub-detail. Now I'm going to say clear it. So how do we create that? It's going to be pretty, it's really very straightforward. We'll just look at this. My create datasets call creates 3 client datasets on the fly, making them essentially owned by each other, except for the top level is owned by the form. And then I'm using field defs. So here's 2 different ways of dealing with field defs. I could say field defs.add, or I could say field defs add field def, which returns a field def, and then I can work with it. So here I'm adding 3 fields. Now here I'm adding 1 top level field, and then I'm adding the fields for the children, and then the sub going to the field defs for the child defs of the field def for the sub detail. That's how we get that. So if you take a look, and you can see it's pretty straightforward. We create the top level client data set, then we create a nested data set field for it. And in this case, the dataset field is an FT dataset. That's the data type. And then we're creating nested datasets for that nested dataset. And then we're adding the fields. So here's add, and here's add again down here. Finally, we create the top level client dataset. And in here, what I'm doing is I'm actually using, you'll notice over here, I'm using field by name to get a T field, and I'm casting as a dataset field to assign to the detail and sub-detail client datasets dataset field property in order to hook those fields up to the DB grids there at runtime. So once again, that's all. I'm ready to go. I can add this. If I save as XML or save as CDS, I'm saving the structures, including the nested datasets and the data. In this case, the client datasets are in their default caching updates mode, so they would actually be caching these changes. If we were to later load this, we would actually have the change cache that we could manage. Okay, let's look at the last example, which demonstrates how to create these nested datasets at runtime using T fields. And it's very, very similar, except obviously instead of using field defs, we're using T fields. So in this case, I'm creating a field, and when you create fields, you assign them to, you have to assign their dataset property to associate that T field with the proper dataset. And you'll notice down here I'm getting to this last field, and it's a TDataSet field construct that I'm calling, and I'm associating it with the top dataset. Now, just like we did with the design time element, I then take the child client dataset, and I assign its dataset field to the dataset field in the master table. Then I can create the individual T fields for that table. And then here we're doing this again, taking the subdetail and hooking it, or the client dataset for the subdetail, hooking up to the dataset field associated with the detail, and again creating the additional fields. Finally, we call, just on the top level dataset, we call create dataset. That creates the dataset and all its nested datasets. And then now we're hooking up data sources to the individual client datasets. So this doesn't look any different in terms of how it operates from the last one, but we're using T fields to create our datasets instead of using T field defs. Well, you've seen the benefit of nested datasets, but I want to leave you with one final thought, and that is nested datasets, while they're very, very powerful and very cool, they're not appropriate for every use. Specifically, data stored in nested dataset fields is much more difficult to search for. An example will make this really clear. Remember the customer contact or the contact management software I talked about earlier in this presentation, where you have a client dataset that has details about each contact. So there's a contacts table, and each record is a different contact, but there's a nested dataset field that has a phone number. Well, imagine that you get your phone bill and there is a very, very expensive call, and you're wondering, who was that we called that cost so much? In order to find that phone number, if you've used nested datasets, you go to the first record and then you search the nested dataset field. Then you go to the second record and search for the phone number. Then you go to the third record and search for the phone number. If instead you had used two separate client datasets, which you could hook up in a master detail relationship using the master source and master fields properties, still, if we had two separate tables, we could just simply go to the phone number field of the phone numbers table and do a find key or a locate, and instantly locate the record. Then we look over at the customer ID that it's associated with, and you look that up in the customer table, and now you know who had called. Again, though, if we used nested datasets, we'd have to systematically go to each record and then search for the phone numbers there. So it's not perfect. However, you just need to take into account exactly what your needs are as far as the data goes when employing nested datasets. And certainly, if the nested dataset was created by a dynamic link to an underlying table, you do in fact have a phone numbers table out on your database, and you could just search on that. It's really, this situation is mostly relevant when you are using a standalone client dataset as a relational database in a single file or in a flat file type application. Thank you for attending this talk. I want to point out that although those are pretty simple examples, that if you want to download those examples, you'll find them at www.jensendatasystems.com/CodeRage9. And you can find the code samples from my other CodeRage talk at that location as well. I also invite you to visit www.delphideveloperdays.com to learn more about our annual Delphi Developer Days tour. Bob Swart and I visit a number of cities in North America and Europe each year with our Delphi Developer Days tour. All attendees get our Delphi Developer Days course book, which is in the last couple of years, it's been 450 pages. It's a real book. It's got a lot of content. All the presentations we do are in that book. And that's especially useful because we do have a lot of breakout sessions where I present in one room and Bob is presenting another topic in another room. You're not going to be able to attend all the talks. So we've produced this course book for you so you can read the paper for those presentations that you're not able to actually attend. I also am proud to announce that I'm coming out with a second edition of my Delphi In-Depth Client Datasets book. That should be available starting about mid-November, but the final draft has been written and we're in production mode right now. If you want to learn more about that book, you can do that by going to www.jensendatasystems.com/CDSbook. Also, I want to invite you to look into a couple of the conferences I'm presenting at this fall. I'm going to be presenting at EuroDevCon, which is combined with the Entwickler Conference number 18 in Cologne, Germany on November 3rd through 5th. I'm also going to be presenting at the Software Development Conference, which is an annual conference by the Software Development Network in the Netherlands, and that will be in Arnhem on December 1st and 2nd. Finally, if you need to get in contact with me with follow-up questions, you can email me at cjensen@jensendatasystems.com. You can learn more about my services, consulting and development services, and training at www.jensendatasystems.com. And I ask that you follow my blog at caryjensen.blogspot.com and follow me on Twitter at twitter.com/caryjensen. Once again, thank you very much, and I look forward to the upcoming.
Yeah, let's go ahead and go over these. So you said client datasets can be connected to third-party datasets using the provider components. Is FDMemTable limited to FireDAC datasets? I guess that might be from the last session.
That's from the last session, but yes, FireDAC currently can load its data from FireDAC datasets, and you don't have an easy way except for by using a batch move type operation to move data from other datasets. I suspect we'll see that connectivity improve over time.
Would nested datasets also be usable for defining new lacking, or for defining new lacking records in different tables?
So my reading of that question is, are nested datasets useful in situations where you don't have an underlying database with master detail relationships? The answer is definitely yes. I may want to transport I gave the example of the transportation company that wants to provide a driver with information about their stops, the orders are leaving at each stop, and which packages are associated with each order. There may not be an underlying database there. That could be created entirely in memory using either the design time or runtime structure definitions using field defs or fields, as I demonstrated towards the end of the presentation. I find it very convenient to use the nested datasets to transport master detail type data even when there's no underlying database.
Would nested datasets be something similar to a view made from a lot of tables with from table 1, left join table 2, etc.?
Yeah, no, it's not, because in that scenario, when you have a view that, or even just a query result that has links with some queries, what you end up is each record has information from the multiple tables. And nested datasets are not like that. A nested dataset is a dataset in a field of a record. And that's quite a bit different.
Okay.
So with the nested datasets, you actually have 2 or more tables, but with a view or a query with subqueries, you have one result set, one row and column structure. With nested datasets, you have multiple row and column structures.
So Alf expands on his question from earlier. He says, thinking of a customer or about a customer exists, but a certain order is lacking. Could that lacking order record be inserted?
Not only can that missing order be inserted into the detail table, into the nested dataset, but if you ultimately are going to take that data and save it to a file or call apply updates on the client dataset, that inserted detail record will be inserted by the top level dataset with the call to apply updates in the situation where you're connected through a dataset provider. If you're writing to a file and you call save to file, that inserted record would be written to the underlying file, or stream if you use save to stream. So yes, this is extremely valuable. With client datasets hooked up to dataset providers, the nested dataset gives you a changelog managed by the top level client dataset that is applied within the transaction of the apply updates call.
Is there an easy way to encrypt the data in a file that was written out using client dataset or FDMemTable? For instance, XML or JSON type files. One would need to stream it and then encrypt, decrypt the stream upon writing, reading?
That's correct. And so that question actually answered itself. That's exactly what you do. I've done this on numerous occasions. In fact, here's how I go about it. If I'm really concerned about security, what I do is I'll take either the XML data property of the client dataset, or I'll write out the JSON to stream from the empty mem table. I then encrypt. I first compress that data, then I encrypt it, and then I take that stream and either write it to a file or send it across the internet. And then you just do the reverse when you're done. You retrieve this encrypted, compressed file, you decrypt it first, then you decompress it. You want to compress before you encrypt because compressing XML or JSON is very efficient. Compressing an encrypted file, there's very little to tokenize in an encrypted file, so you wouldn't get much. The compression would do very little for you with an encrypted stream.
Yeah, and actually, encrypting compressed files is more secure than non-compressed files because duplicate data is the bane of encryption. If I have a many-to-many relationship using interaction table in between table A or A1 minus N, table B, AB N minus 1, table B, how do I write this out using nested datasets?
Okay, so an intersection table, so what we have, if I understand this correctly, we have one to many to many. So really you are going to have to take that intersection table and make it a nested dataset, and then the detail table of that nested dataset would be that sub-detail. By the way, this brings up a point that I didn't really stress enough, which is nested datasets aren't just the one to many to many to many. You could have a top-level nested dataset, and that nested dataset have 5 nested datasets. And each of those nested datasets can have 0 or more nested datasets. So it's not, you could have a master with 3 details, and one of those details has 2 additional sub-detail tables. But in this case, if we wanted to capture in a nested dataset a third-level table where there is a table between them, that really is a one-to-many relationship, if I understand the question. If I've got that wrong, then I don't think there's a solution that would suffice here.
Yeah, he elaborated on it, said it would be one-to-many to one.
One-to-many to one? Yeah, that's exactly, in fact, yes, that's a trivial matter. Yes, it could be one-to-many, and then the many has only one detailed record. Here's an example. If I took my order, I got my customers, and then I got my detail being customer orders. Well, with a customer order, there is only one employee who's associated with that order sale. And so you could have a detail containing the information about that employee. It's a nested data set of the orders table that always has 0 or 1 records.
Okay.
So yes, that handles it, but it is a one-to-many. It's a one-to-many to one, but that's only because the data model says that, and you have a constraint on the employee end field of the orders table, it's going to link to only 0 or 1 employees, so that sub-detail table will have 0 or 1 records.
Christopher says, you show both the mid-level CDS and the third-level CDS owned by the top-level CDS. Would or should the third-level CDS be owned by the mid-level CDS instead?
It could be, but ownership has absolutely nothing to do with the relationship. It has to do with who's responsible for cleaning up that data set when its owner is destroyed. Having both the detail and sub-detail owned by the same master table or master client data set has the same effect as having the detail table being owned by the master and the sub-detail being owned by sub-detail being owned by the detail, in that once the master is destroyed, there will be a, through ownership, destruction of both of those detail and sub-detail tables, but the ownership has nothing to do with the master-detail relationship itself. We could have all 3 client data sets owned by the form or owned by a T application or a data module. It doesn't matter.
Bruce pointed out that the link on your slides was CDS Book, which is the first edition, but CDS Book 2 is the second edition.
We have actually updated the CDS Book link, and now Bruce, if you were to refresh that page, you would see that it has the information about the old book, but it also has information about the upcoming book and link over to CDS Book 2.
Yes.
So that's something that I overlooked. I apologize.
A lot of people saying great presentation, lots of good information. Oh, so John said he would love to have an example showing compressing, encrypting, saving, and then loading, decrypting, uncompressing.
I agree, and it's using the open source material of Lockbox and Abriva from InfoPower. It would be nice to create a little example like that. In fact, we could even go further and create a descendant client data set or FDMEM table that encapsulates elements of those libraries to have a encrypted save to file and an encrypted save to stream. That'd be cool.
Yeah, that would be great. There's lots of little options to integrate things like that. So very cool. As I mentioned before, the Delphi Developer Days is a great conference, and actually I haven't been to the full SDL, but I have been to the other. Thank you so much, Cary, for your time and for connecting with us here from Germany.
Absolutely, it was a pleasure.